Node.js, as you may have heard, is built on top of the Chrome V8 JavaScript engine. So to properly understand what Node.js is and what it does, we must first take some time to understand what V8 is, how it works, and what JavaScript engines are in general. To do that, it's worth taking a step back and defining a few key concepts around this topic first. First, it's worth understanding that modern-day computers only understand machine code, and that machine code looks nothing like the programming languages you may write. Machine code looks more like a string of ones and zeros than it does JavaScript or C++ or PHP or Ruby. So most programmers never attempt to write raw machine code instructions. Instead, they write quote-unquote high-level programming languages. High-level languages are those that abstract away the close-to-the-metal operations that the CPU is doing, like loading, adding, comparing, and storing numbers to and from RAM, and let the programmer create variables, perform operations, execute functions, and the like. The terms high-level and low-level are ambiguous and relative, though. If you ask a Visual Basic programmer, Ruby might be low-level. If you ask a Ruby programmer, C might be low-level. And to those who work closely to the metal in assembly and machine code, all of these are high-level languages. In reality, languages lie on a spectrum, and there's no clear point where low-level ends and high-level begins. But one thing is for certain: JavaScript, C++, Ruby, and all the other popular languages are completely foreign to the computer itself. It doesn't understand them. So broadly speaking, one or more things need to happen before a computer can run a program written in a modern programming languages. This is the work of three main groups of software: compilers, transpilers, and interpreters. There are also others such as assemblers, but those are outside the scope of this course. Compilers, they take source code, that is code written in a programming languages, and turn it into machine code, or assembly, or bytecode, or object code, or something else low level, so that the computer can run the program easily, or only has to take a few short steps to run it. Compilers create executables. These are programs that are ready to be run. Transpilers take source code and generate more source code of another type. Common examples of transpiling include turning CoffeeScript into JavaScript, or turning less or Sass into CSS. Interpreters, they take source code and directly execute it themselves. They do this by performing real-time intermediate steps, such as compiling pieces of the code as it goes and optimizing aspects of it for performance. So you can think of interpreting as compiling plus executing, except interpreters don't leave behind any artifacts, any executable programs like the compilers do. So what is V8? Well, V8 is what we call a JavaScript engine, and JavaScript engines are interpreters for JavaScript. V8 compiles JavaScript down to native machine code and executes it. It also optimizes the code at runtime to make it faster. V8 is a standalone application, but people rarely interact with it directly. However, if you've used the Chrome web browser, you've already used V8. If you've opened up the console and debugged JavaScript on the client side, the repo you're interacting with is V8. There are a couple other JavaScript engines you're probably familiar with. If you've ever built an app in React Native, or if you've ever used the Safari web browser, you've been interacting with a JavaScript engine called JavaScript Core. V8 was written by the folks at Google in order to power Chrome, while JavaScript Core is written by the folks at Apple largely to power Safari. There's another popular engine called SpiderMonkey, which is developed by Mozilla and is used inside of the Firefox web browser. SpiderMonkey and V8 have alternately both been used inside of MongoDB so that Mongo can understand the JSON commands you send to it. Interestingly enough, SpiderMonkey was actually the first ever JavaScript engine, and it was written by Brendan Eich, the same guy who invented JavaScript. He was working at Netscape, and he wrote SpiderMonkey in 1996 to be used inside of the Netscape Navigator web browser. In 1998, Netscape created Mozilla, the current parent of Firefox. There's also a JavaScript engine called Chakra, and if you've ever used Microsoft's Internet Explorer or Edge web browsers, you've used Chakra before. Modern web browsers perform a lot of tasks, but many of them include parsing and executing JavaScript. So in a way, you can think of a web browser as an application that looks at JavaScript files and sends them to an embedded JavaScript engine, like V8, so that the JavaScript can be executed. So in this way, browsers are built on top of a JavaScript engine. Now that you've got that concept down, we can turn to look at Node.js, a different type of application that is also built on top of a JavaScript engine and functions much the same way. Node.js looks at JavaScript files and then sends those files to an embedded JavaScript engine, V8, so that the JavaScript can be executed.